So we're looking at 7.2 day 2, and we're talking about a clean ratio when we're looking at to solve a problem to set up a proportion. And the proportion that we've got to set up is a situation in which we have to have a nice number to make a scale factor. Okay? So I'm looking at 9 and 6, and we separated them out. But the idea of this is once I get this, and like it was mentioned, DE and AD are corresponding sides that we've got going on. I'm looking at this situation. 6 to 9 as y is the 5. Now, why did I go 6 to 9, y to 5? I went to small to big. So y to 5, small to big. Does that make sense? Okay. And then if I wanted to flip it around and go big to small, I would go to the nurse's office. Okay, that's a good enough pass right there. Wow. So when we're looking through this, make sure you understand as we're looking at it, the relationship that we're going to solve. Okay? And then we just cross multiply. Are you okay with 10/3 is equal to y? Yes or no? It's close. But I don't want you guessing. I want you to actually have a fact on how to set something up. Questions? Promise? Okay. Your turn. I would like you to use, remember, you have a nice clean ratio of 9 to 6 or 6 to 9. I don't care how you set it up. But set up your other side appropriately to solve for x. Go ahead. It's very similar. First of all, I asked you to solve for x. Corresponding sides. We've already set up a ratio of small to big, right? So I've got small, I have big, small to big. If they're proportional, and they say they are because they're similar, then I should be able to set it up corresponding sides small to big that way. Are there any questions? Once I do the setup, you're in algebra land. Go for it. Get it done. You okay with going there? I suppose I set it up there, but are you okay with 5? Any questions? Now, this is something I would expect if I were you as a student to see on the test. I can almost guarantee it. An overlapping shape, you being able to determine what's going on with the use of proportion. Okay? You set up the ratios, you set them equal, and you solve the proportion. Okay? Any follow-ups? Anything that was a guess or anything? Okay, I had some funny looking faces, but they look a little bit more relaxed, so I'm thinking going on is an okay thing. So let's go sliding on. Now we compare heights on this next one. The concern of this, some people wonder why we're doing it twice. Okay, in this problem, we're asked to determine if a poster design that's 6 inches high by 10 inches wide can fit in a space that's 4 feet high by 8 feet wide. Okay. Now I want to maximize this. If I have that 4 feet by 8 feet space and I just took my little 6 inch by 10 inch, I'd be, look, it fit. Okay, but there'd be a lot of white space, right? So I want to be able to have it expand proportionally and to see how big I can actually make it to fit in that space. Okay, that's the purpose of this problem. So in comparing the height needed, I'm going to fix the width at 8. Okay? And people are like, well, what do you mean by that? I already know a relationship that is inches, height, width, that's in inches. And because I'm setting up in inches, I have 6 to 10. Okay? I'm not going to reduce it. I'm not going to worry about reducing it. Okay? So I've got 6 to 10. And now I go from 6 to 10, and I'm going to fix 8. And people are like, where did 8 come from? 8 came from right here. I want to know if 4 feet's enough. And I'm not going to compare them as fractions. I'm just going to find out if I had a width that was 8 feet wide, how high would it have to be to make this work? Okay, so I'm projecting out if I have an 8-foot wide space, if this thing was done, how high would it have to be? So I solve for h. Now, in solving for h, I find out it's 4.8. Okay, now remember, it was on the feet side. So this is 4.8 feet. I need 4.8 feet of height. Will it fit in the space provided? The space provided is 4 feet high. Well, okay. So I can't make it 8 feet wide. Okay, does that make sense? I have a limitation. All right, it's got to be smaller than that. But I don't want to keep adjusting it down. I want to, okay, so I got 4 feet. That's my height. I'm going to just do everything the same and compare it to 4 feet. Okay, now I'm going to resolve with the consideration that 4 feet high is the maximum height. How wide's it got to be? Okay, and will it fit in the space provided? And after I set it up, I just solve. 6w is equal to 40 and divide by 6. I got 6 2/3. Now remember, that is also in feet. Are you okay with the 2 steps I took? Yes or no? Now, it's always dangerous when people are quiet because they're like, really, well, you know, it's not really on the assignment or a test. Folks, it's on the assignment. Okay, same thing. So I'm asking, are you okay with what I've done so far? I'm not quite done because I have to talk about my findings. I've got a word problem, I should have a word answer. So what's this mean to me? I can take my 6-inch high by 10-inch wide design and blow it up to fit in a space that is 4 feet high, 6 2/3 feet wide. Okay, based on my findings, I can do that. I couldn't put it in this space above with an 8-foot wide space because it would have been too big. I would have had to peel it off, and it wouldn't been the pretty design that I made initially. Okay. Now I have some folks when the problems seem to get a little longer and my explanation takes more time than the problem itself, think, oh, they can't possibly do it. All I'm doing is comparing the space with the height and then comparing the space with the width and seeing which one's reasonable. That's it. Okay? And I would like you to try by just getting a push start. I'm doing the same thing, except I'm doing it with a different space. Same size design with a different size space. And I want you to make the comparisons and learn what you're finding. Give it a try. Now, for those folks that are new, my 6th hour, my 4th hour last semester was the times I taped. Just in case you're gone, you can catch a video of the lesson. So I expect you to ask questions during it. I expect you to point out mistakes I have because, geez, it's on tape. Let's just make sure it's clean. Because I'm trying my best to make sure I'm out of the need to review the things I missed loop. So if you're home and you've been just sitting around all day, you might be bored out of your mind, and you know this stuff is pending, you can get it done. Okay, it'll be posted every day by 2:30, 3 o'clock if we're able to get it done. There are times I have technical difficulties and I couldn't tell you why the mistakes were made, but they just didn't work for some reason. That the videos had to be redone, so they may or may not make it into the archives, so I apologize for that. But we're trying our best to make sure that you can go on without me being a hindrance, okay? Now, keep in mind, what about a space that is 3 feet high by 4 feet wide? I find it, I'm looking, hey, that's 5. But that's a width of 5 feet. Will it fit in the space provided? Yes or no? No, because this is, if the width is going to be 5 feet and the other one is 4 feet wide, it's not going to fit. So I'm going to look at the other side. I'm going to say, well, you know, what if I just find the width of 4 feet? Maybe the height's enough. Okay, I'm going to do the same thing. Hopefully you were able to do the same thing, and it's 2.4. That's 2.4 feet. Okay, 2 feet, what, 4.8 inches? Okay, so now I'm going to explain myself. So the largest poster is 2.4 feet by 4 feet. That fit in there. Okay? Hi, kiddo. Thank you. Thanks, kiddo. There's a calculator there you can use, or you can move off onto the file cabinet. Now, if there are questions on this, feel free to ask it while we're going over anything. But any clarifications right now? Are we doing okay? I've got some blank stares. It's always scary. Yeah?
So if your first one does fit, can you stop there?
Yeah, but you know, I always like to check both just to see if the other one would be a better fit. Okay? And you know, I know now with the idea of computers, you can just mock it up kind of on the screen with a CAD program, download the stuff and be able to bring it up and that. But sometimes it's nice to know before you even start going through that process what types of spaces you can be working with. Scale drawing. Up until today, I've been kind of a stickler making sure that it's inches to inches, feet to feet, miles to miles. Want to make sure you have like units, okay? And today when we're working with scale, we don't have to have like units and we can still use proportions. We need to be careful, however, how we set it up and know what units our variable should be in, okay, and realize that as we're solving, okay? And really kind of having a clue on what we're solving for just instead of just a number. So in scale drawings, all the lengths are proportional to the corresponding actual lengths, but I get to mix units in scale drawings. Okay, so we can use proportions to find the actual dimensions represented in stuff, even though we're mixing units. So my example, the diagram shows a scale drawing of the Golden Gate Bridge in San Francisco. The distance between the two towers is the main span. So they're saying in this problem, this distance in the main span is 6.4 centimeters. Okay, and they're asking, hey, what's the actual length? Okay, so I have a model dimension and I have a real dimension, model and real. Okay, 1 to 200. Now notice when I did this model to real, I will drop the model and real monikers, but I will keep my units that I'm using. Okay, because there's a lot of times after you solve something, you go, what were their units? I've got to check that. And if I put it in as I set it up, I can just glance at where I have the variable. Okay, and being able to see where I have the variable will also help me with my setup as well. I'm just going to bring that up so people don't have to look at people's heads. Is that okay back there? Okay, so now I've got this going on and I got 1 to 200. Remember, 6.4 isn't the real model structure, because if it was, I'd win that Golden Gate Bridge thing. 6.4. Whew. Okay, done. I just went across the Golden Gate Bridge. It's pretty quick, right? You want to see that again? I can do it twice. Okay. Almost 13 centimeters. I'm pretty good. Okay. Here's the thing. What is the actual real distance across the Golden Gate? So we got 6.4. And I put it in the centimeters area, so my answer I'm finding is going to be in meters. Okay. After I do all this setup, it's algebra land time. I know how to solve this. Cross product. But know what your units is that you're finding. So I cross multiply. I got 6.4 times 200. I pop it in my calculator. I'm really happy about it all. I'm going to get 1,280 meters. Wow, that makes how fast I just did that pretty impressive, right? I'd still be running, probably tomorrow morning. You guys would probably find me finishing or dying, one of the two. Here's the deal. 1,280 meters is between the two spans. Does that make sense? I also want to talk about the fact that there are other ways to do some problems that we do. The purpose of today is to talk about the use of proportions and ratios in working with problems. Yet in science, y'all have done this problem before. You have 6.4 centimeters, right? You have a unit conversion where you can take and convert units. It's called stoichiometry, but some of you probably not heard of it as stoichiometry, used as unit conversion. I want to get rid of centimeters, so centimeters is on the bottom. 200 meters is on top, is my answer, okay? Now, the reason why it took so long for what I did before is I wanted to make sure you see why my setup was the way it was, but after that, it was quick. Keep in mind, if it's just numbers I'm working with, there are multiple ways to like set it up and get it done. I'm really just using a multiplier. That's like my scale factor multiplier that we've done in other problems before, okay? When I'm doing this ratio and proportion idea, sometimes there's really no other way about it because I'm setting up an algebraic relationship that needs to be solved, and this is the way I can set it up because I don't have a value that's clean to multiply everything by. So let's go on to our next one. Little review, 10A, 10B. Fill in the letters that should be there, please. How you doing? Okay? Now remember, every time you're given a similarity statement or a statement of congruence, gosh, use them suckers. Just go right to them, read them, plug everything in, okay? When you see something like this, the first thing you should do in problem 11, look at the angles. Because if the angles aren't the same, you're done. You can say they're not going to be similar. So you got to make sure you check angles first. Then after the angles are the same, then go for side proportionality. Because other than triangles, that can still be two things that are not similar. Okay? So, angles. I'm just doing a visual check, checking all my angles. They have pairs. Next thing, 12, 18, 24, that's my top. 8, 12, 16, and 16, that's my bottom. I'm comparing them. I'm setting up an extended ratio. Or I should say extended proportion, not extended ratio. We've got 4 ratios in that extended proportion. Now, the next step. If they're truly similar, they should all reduce to the same value, my scale factor. We okay with that? So now I can write my scale factor. I can tell you right now that it's similar because I have a scale factor, and I can write my statement of similarity. That's really connecting the two shapes together using their names. Okay? Questions regarding at all what we've done? Doing okay? Now, as people are finishing out that problem and thinking about it, okay, and I'm sorry for the space. The intention was to use that space for you guys underneath the other problem because I left so much there. Answer 12A. Kind of start reading it. Let's look it over. Okay. You've got a building. You've got an architect that's designing a building. Okay. You got a scale drawing. So my clean numbers I'm going to use are 1 inch to 15 feet. Okay. And I'm going to use that inches over feet. Okay. So I've got 1 inch to 15 feet going on here. I've got it here someplace. Okay, 1 inch to 15 feet. As I read, where's the 48 go? It goes to 4 feet because that's my real value, and they want to know what my model value is. So I pop that in, I have X in my real, and that's the thing I'm supposed to find. So long as you keep your eyes on what you're supposed to find, you're going to be fine. But make sure you keep in mind what your units should be in as you're working your problem, okay? So now, I cross multiply. I got 15x equal 48. I divide by 15. I get 3.2. Are you okay? But now, just like my kids, every time they go, Dad, can you help me with this? And I go, okay, but wait a minute. You've done this one. Oh, yeah, I'm right with that one. You got 3.2, and it's a word problem. They go, yeah. What, 3.2 cookies, 3.2 people, 3.2 what? Well, I didn't want you to help on that one. I want to know what that 3.2 is for. And well, I don't know. Read the problem. They go, oh, it's 3.2 inches. Oh, I said, great. Then write it down. Okay. If you have a word problem, you have an opportunity to describe that word problem, and the explanation is supposed to go with it. Okay. It's always the most popular missed questions, or the ones that people skip because they're going to ask that tomorrow to make it look like they're part of what's going on with their assignments. Make sure you ask, because in geometry they're all word problems. Okay, you can't just go skipping those. Your turn. Do B. After you do B, do 13. And pretend 13 is like a test question, because they're pretty much like test questions. The only difference is you guys are trying them for the first time. So go ahead, get B done, and then go on to 13. Now again, if the building is 90 feet wide, how wide should the scale factor be? Everything is I'm setting up is the same. I'm just putting 90 in instead of 48. And now I just go to town and get it done. Okay, X is 6, so I got a 6-inch wide building. Are there any questions on those two? Okay, go ahead and get after 13. It's very similar, but it's very much like something I'd expect of you to know, be able to be successful on the test. First of all, your toe okay? And secondly, are they going okay? Okay, cool. You guys doing okay?
Yep.
Okay, cool. Yeah, what do you have? That one, it's 45 over, is it 9? I'm feeling like it's a 9. Let's see what we've got. I've got 15 goes in the 120, and then I got 45, so it shouldn't be 360.
Did I do this wrong?
But the 45 centimeters, and it's 15 centimeters, 45 should be up with 15. You okay with what I'm doing? Okay. Now, when we're doing this next one, a scale drawing of a building was made using the scale 15 centimeters to 120 feet. I'm setting you up the same. Okay, I got centimeters to feet. I'm reminding myself 45 should be, because it's centimeters, up with the other ones. Are you okay with that? Then after you do the setup, and quite honestly, that's the hardest part of these problems. What am I going to do? How am I going to go after it? Once you set it up, cross multiply, you get 360. And again, 360 what? Cars, which would be pretty cool. One for every day. Okay. Actual building is 360 feet tall. Does that help? Is it going okay? Now, read 14 and use your critical thinking skills. Put your problem solving cap on. I don't really have to present something different. I've already talked about orders and issue. Order matters when we're talking about similarity, when we're talking about scale factor. If I define scale factor order, it matters. If I don't care which way. But in this case, pay attention to order. It's here someplace. How is it that you guys say, oh, it's 15. I'm way ahead of myself. I'm sorry. Let's look at, but it's still order, and I apologize. Hey, since I set you up, look at 15. Let's look at 15. We'll come back, because I got that going on. I hate it when I'm thinking I'm someplace else and I'm not. Okay, especially when it's Monday and you're feeling like it's a Friday. That's never good. But at least it is Friday today, right? Okay, good. 15. What do you think? All I'm doing, because I switched the order of the scale factor names, I switched this to this because order matters. All I want you to do is realize that order switches. Be careful. Some people go, boom, I don't get it. I don't get what this thing is. Just be careful. For most people, they just pay attention to what they're reading and then read the next question. They'll flip it without even me talking to them about it. So be careful about that. Let's go back to the one I skipped because I was ahead of myself. In 14, excuse me. Can you find a clean scale factor? Do you know what I mean by that? A scale factor with numbers and reduce it. Which two numbers would you use? Nice. Do you see them? Because these are, and some people are like, okay, great, they're numbers. But check it out. DC is here. UV is right there. Are you okay? Yes or no? Okay, so the next step. Reduce it as a scale factor. Tough, right? Okay, well let's talk about a couple tricks. First, go 17 divided by 25.5 in your calculator. If you have a graphing calculator, you have a different thing to follow. If you have a regular calculator, you have that decimal to fraction button. You can hit the decimal to fraction button. It'll go 2 to 3. If you have a graphing calculator, do you have a math key on your left side in the column? Hit math. And do you see frac? Hit enter again, and you will have 2 to 3 as well. Okay? Now, if you didn't have that opportunity to practice that, and those people around you did, check them out, because some of those little key tricks really help on days that you're just kind of making mistakes and you go, oh, geez, I can't believe I'm doing it that way. But now, when I was you, what we would do, to keep the number small, what do I multiply something that's in 0.5 to get rid of the 0.5, to double it? I mean, if I double 0.5 and make it, a full number, like a full integer, okay? And then make it bigger. And we all started talking about 17 and 25.5. If I multiply the top and bottom by 2, I get 34 to 51. I can factor 34 and 51. 17 times 2 is 34. 17 times 3 is 51. So I take a 17 out and I get 2/3. So I do it the same way, except I learned tricks to do it without a calculator because calculators were really expensive. And I just keep doing it because it's factor skills. Okay? But keep in mind, I've set up a 2 to 3 scale factor. Now the reason I'm doing that is because now my numbers are small. I'm supposed to solve for y. And right now, I have a scale factor that is 2 to 3. Ask the question, what do you got, Grev? You promise? Okay, all right. So I've got 2 to 3 as my factor, my scale factor. Small to big. You okay with that? 2 is smaller than 3, so 2 is the small, 3 is the big. Small to big. And probably I should underline the one that's in the corresponding spot. Well, I did underline the one in the corresponding spot. But it didn't matter because they're parallelograms and their opposites are the same. Are you okay with this so far? Since it's small, 3y minus 3.5, 3y plus 6. Are you okay so far? We got our setup, and now I can solve. Go ahead and solve. Remember, cross multiply, make sure you distribute. Make sure you distribute to both members. Okay. Now, I always got some folks going, oh, you know, it's not like he's going to test on this. Folks, I ain't going to waste your time. You're testing on this. Okay. Make sure you're comfortable with it. Make sure you're comfortable with setting up an extended proportion that has a funky algebraic result. Okay. I showed you a trick to make it so that if you have really ugly numbers, to make them nice, to make it easier to solve. So make sure you're comfortable with that. If you're not, make sure you come on in and we chat about it to improve your skills on that type. Now, after you get that solve going on, I got 6y plus 12 equal 9y minus 10.5. I've got 22.5 is equal to 3y. After I subtract, and I got 7.5 is equal to y. Okay? So, works out pretty slick, right? Now, here's the deal. If I chose not to do that, we all knew that 17 was the 25.5. That's what we started with, right? This is how ugly that cross product gets. Which one would you prefer? Isn't it nicer to see that scale factor used to help us out? So make sure you recognize it. I'm not saying the other way is impossible, and it's not wrong. It's just, you know, if you have some skills to make it easier for you, wouldn't that be better? Okay, so I just want to make sure I clean that up for you. Okay, I don't care which way you do it, it's the same. Okay, same answer. Both of them are 7.5, and we're golden. Now, you have a self-quiz right at the bottom. Okay, you've got 5 questions. You're asked about finding angles. You're asked about finding missing sides. Please go ahead and do so. Okay. How'd you do on finding the angle values? Keep in mind, angles in shapes that are to be similar are congruent. So we just use our triangle sum theorem skills to find the missing values. We do okay with those. I just put them in on the shape just to make sure you guys were able to find them quick. We okay? Now, the next step. Remember yesterday I talked about that scale factor? Today I kind of started with the scale factor a little bit. Talked about scale factor. Hey, we can reduce this. We can get that done. Scale factors can be used as a multiplier. Since I'm going from one triangle to another and I have 2 values that are clean, no variables with them, easy to find a scale factor. I got 20 and 24. And I have you do that right off the bat just to make sure, hey, we got 5, 6 as a scale factor. And remember, I gave you the direction of the scale factor, which means I wanted a certain order to have it represent so we could talk about it. I got 5 to 6, okay? The small one's on the left, the big one's on the right. And some people have a hard time, how do I know that? 20 and 24 are corresponding sides. This is from the small side triangle, this is from the bigger one. Okay, that's how I know. In order to go from the small one to the big one using scale factor, I've got to have a value bigger. So I manipulate my scale factor. I have two choices, 5/6 or 6/5, which would result in a larger number when I multiply, 6/5. So if I have 40 and 40, this and this correspond, DE and RP correspond, 40 times 6/5 is 48. And I've got 36 in FE. 36 times 6/5 is 43.2. Using scale factor. Now remember, scale factor is real slick to be able to use if I'm just working with numbers. If I'm working with variables, I should probably be setting up that proportion and being more careful about how I'm going to get there. Because after I get my scale factor, it's really easy for me to check to see if I'm right. I should be able to take my 43.2, my 36, divide them, and come up with 6/5. Okay, because it should be the same scale factor. Okay, now what we've got going today, we're going to correct your assignment. And after we do that, we're going to hand in your 7-1A, 7-1B, 7-2A, and the remainder of the time is your work time. Okay.